Hello, so here's your warm-up today for Unit 4, Lesson 16. So Lynn is comparing the cost of buying cookbooks at different online stores. You were to match each expression to the store that sells them. And so we're going to break that down and talk about that for a minute. So store A is selling them at $9 each and offering free shipping. And so if we know that T is our total cost, which told you down at the bottom, and you could have saw that on the expressions that you were given. They were all T equals. And then N is the number of cookbooks that each store sold or the person was buying. So the first one was T equals, so the total cost is equal to $9 times the number of cookbooks that were sold. Okay, so that's store A. Store B is still selling them for $9 each, but they're charging a $5 shipping fee. So the total cost is now equal to $9 times the number of cookbooks plus this $5 for shipping. Okay. Store C is selling them for P dollars. So they're changing that $9 to be available for any number of cost for the cookbook. So it's now T equals P times the number of cookbooks, and then they are still charging that $5 for shipping. Okay, so now we've just switched out that $9 for any amount of money using the variable P. Then the next one, store D, is selling them for P dollars. So we still have T equals P times N, the number of cookbooks. And now, instead of a $5 shipping fee, we have F. And so we can now charge any amount of shipping. So this function allows the person to compare multiple stores and be allowed to switch out the variables for any amount of cost of the book, any number of books, and any cost of shipping. And they'll be able to use this function and find their total cost that they would have to pay for those books. If we wanted to take that equation and we knew our budget, so if we had a total budget that we wanted to use, that would be represented by the variable T, total cost. And we knew some of the other variables. What if we didn't know the number of books that we wanted? Well, we could take that equation, T equals P times N plus F. And I want to solve this for N, so I want to isolate this variable. I'm going to write an inverse function that allows me to plug in all of those other variables and figure out what number of books I would be allowed to purchase for that price. And so we would just undo all of these steps. So following your order of operations, you're going to do those kind of reverse. So we would subtract F from both sides. And we would have T minus F equals P times N. And I almost have N by itself. Now to undo P times N, so the cost of the book times the number of books, I would divide by P. Okay, and so now I have that variable isolated, so it would be equal to N would equal T minus F divided by P. And so this would be the inverse function of our original one that would allow us to find the number of books I could purchase given a total cost, a total amount for shipping, and a total purchase price for the book that I'm purchasing. All right, so let's look at another example. If we know the temperature in degrees Celsius, we can find the temperature in degrees Fahrenheit using the equation F for Fahrenheit equals 9/5 C plus 32. So we want to fill in this table so that we know the temperature in Celsius and Fahrenheit at given intervals. So if I know the temperature in Celsius, I can just plug these values in for C in the given equation. So you can go ahead and do that. So F, let's not use a highlighter here. So F equals 9/5 And instead of C, I'm going to plug in 0 plus 32. And then we would plug in 100. So F equals 9/5. And instead of C, we would plug in 100 plus 32. And then F equals 9/5. And instead of C, I would put 25 degrees plus 32. And we can find those calculations fairly easy given you have the use of a calculator. It's just simple multiplication and addition. But if I wanted to find the Celsius from the Fahrenheit, so now if I have the Fahrenheit, this equation is going to cost a lot more work because I would be plugging in 104 over here where F is and have to solve for C. And so that would cause you to do several more steps. What might be easier for you to do is to write the inverse of this function and solve it for C so that you can just plug the numbers in like you did for the ones above. So let's take this function, F equals 9/5 C plus 32. And we're going to solve this equation for C so that we can plug F in and get our answer. So to undo this, we're going to start by undoing the addition. So we subtract 32 from both sides. You have F minus 32 equals 9/5 C. And I'm running out of room here. So we have 9/5 C on this side, so that means we're multiplying whatever the temperature is in Celsius by 9/5. So right here, you can do two things. You can either divide by 9/5 on both sides, or since we have a fraction, you can use the opposite reciprocal and you can multiply by 5/9 to cancel that out to get 1. And remember, what you do to one side, you have to do to the other side. And that makes our answer a little bit easier to find because we can leave it and those cancel each other out. You're left with 1. So we now have C equals 5/9 times F minus 32. And so that is our inverse function. It now allows us to plug in the temperature in Fahrenheit and solve for the temperature in Celsius. And so we would continue that trend by plugging in 104, 50, and 62.5. So we could plug in 5/9 times 104 minus 32. 5/9 times 50 minus 32. And the last one would be 5/9 times 62.6 minus 32. And that would allow us to find those answers more quickly. And you should have gotten 32, 212, 77, 40, 10, and 17. And so hopefully you were able to calculate those in your calculator because it's just doing the subtraction first. Down here for C, you have to do what's in parentheses first and then multiply that by 5/9. And up here, you had to do the multiplication first and then add 32. All right, these graphs represent both of those functions. So every time we have an equation, you can see that as a graphical representation. So this first one was Fahrenheit equals 9/5 C plus 32. And so you can see that C is our input. So it's our X value, and it is on the X axis. And so our input is 0. Our X is 0. Our output is 32. When our input was 100, our output is 212. And so F is our output, temperature in Fahrenheit. And you can see that those correlate to an ordered pair. At 0 degrees Celsius, it's 32 degrees Fahrenheit. At 100 degrees Celsius, it's 212 degrees Fahrenheit. On the second graph, it is the inverse function, and we have to switch pins here. We have C equals 5/9 times F minus 32. And you can see that we have C is no longer our input, it is our output. Okay, and so at 0 degrees Celsius, it is still 32 degrees, not 100. And so F is now our input. So that's how those inputs and outputs have just been switched. The X becomes the Y becomes the X. Okay, so I want you to try another one. So take a minute and see if you can figure out if we have this equation for R equals 9/5 times C plus 273.15, defining the temperature in degrees Rankine as a function of the temperature in degrees Celsius. See if this equation, C equals R minus 491.67 times 5/9 defines that inverse function. So some of you might want to try to work backwards from this one. I suggest let's just start with the first one. So if we have R equals 9/5 times C plus 273.15. We need to solve this equation for C. So our goal is to isolate this variable here, and we'll get the inverse function. To do that, we cannot subtract 273 first. You have to distribute the 9/5 first. So we have R equals 9/5 times C is going to give you 9/5 C. 9/5 times 273 is going to give you 491.67. So now that we've distributed the 9/5, now you can do that subtraction and subtract 491.67 from both sides. So you have R minus 491.67 equals 9/5 C. And we have a fraction being multiplied by the variable again. So you can either divide by 9/5, or I choose to multiply by the reciprocal so that it keeps it a little more simple when you're looking at it. So we can flip the fraction and multiply by 5/9, and that will cancel those out, and we're left with C. What you do to one side, you have to do to the other. And so we can leave that looking like a distributive property. So 5/9 times R minus 491.67. And so that's showing us that we have to do the subtraction, R minus 491.67, and then multiply that by 5/9. If you look at what they had up here, they have R minus 491.67, doing that subtraction, and then multiplying it by 5/9, which is the same thing that we have. We just have the fraction in front, and that is common practice. When you are solving algebraic equations, it is a best practice to have that fraction in front so that you know that has to be distributed and multiplied. With it written at the back, sometimes it gets left out and you end up doing operations and then realizing you have to multiply those. All right, our last problem. We have the admission of a carnival that costs $5. Tickets for games at the carnival cost $2. So the equation C equals 5 plus 2t defines the function in the situation. What does this function represent? And then we need to look at what the inverse of this function represents. So if we're looking at this, we've got C. So we think C is going to equal the total cost of the carnival. Okay. And then 5. The 5 here, looking up at the problem, it costs $5 for the admission into the carnival. So that's going to be your general admission. Just to go to the carnival, you have to pay $5. And then we have plus 2t. So 2t, we know that tickets for the games at the carnival cost $2. So this represents $2 per ticket. Okay. Excuse me. So if we're going to write the inverse for this function, we would be solving for t. And so that would tell us the number of tickets that we could purchase if we knew the total cost we had. Okay, so we would need to take that equation and solve for t. So if we have c equals 5 plus 2t, we have to start by doing the reverse of our order of operations. So we would have to first subtract 5 from both sides. That would give us c minus 5 equals 2t. Now we have 2 times t, so that's multiplication. We have to do the opposite, which would be divide both sides by 2. So those would cancel out, and we would have t equals c minus 5 divided by 2. So the number of tickets that we could purchase is equal to the total cost we have minus the $5 per admission divided by the $2 per ticket. And so this would be our inverse function. Number 3 is asking, does the equation t equals c minus 2 divided by 5 define the inverse of the function in the first question? And so that would be no, because we found the inverse of the function, and they subtracted 2 and divided by 5, where they should have subtracted 5 and divided by 2. All right, and so hopefully you have a little bit better understanding of inverse functions and how to use those to solve problems.